Hello, in this lesson I want you to apply the properties of trapezoids and kites. Some vocabulary you're going to come across are trapezoid, bases, legs of a trapezoid, base angles, isosceles trapezoid, mid-segment of a trapezoid, and kite. A trapezoid is not a parallelogram, unlike everything else we've done so far. A parallelogram has two pairs of opposite sides parallel. A trapezoid has exactly one pair of opposite sides parallel. Those two sides we call bases. The other one are called legs. Trapezoid comes from an old English word that means table. So kind of think of a tabletop. That's where it comes from. If we have an isosceles trapezoid, the legs are going to be congruent. And the angles along the bases are called base angles. And in an isosceles trapezoid, you have two pairs of base angles that are congruent. Because you still have one set of sides parallel, the angles along the leg are going to be supplementary. Like in here, angle F and angle G will be supplementary. That's true in any trapezoid, not just an isosceles trapezoid. And then the converse is true. If you have a pair of base angles congruent in a trapezoid, then it's isosceles. If you have an isosceles trapezoid, the diagonals will be congruent. However, they're not going to bisect because bisect would be a parallelogram. They're going to be congruent, but they're not going to meet in the middle. Because if they meet in the middle, then it would be a parallelogram. Here's the proof showing why your diagonal is going to be congruent in an isosceles trapezoid. Because we have this, we're going to look at overlapping triangles here. I'm going to have DC overlapping with itself because you have two triangles there. We know, since an isosceles trapezoid, we know AD is congruent to BC. And then we have angle ADC is congruent because the base angles are congruent. And then what happens is we have side angle side for those two triangles. So AC is congruent to BD by CPCTC.